This is problem 3 from chapter 19. Show that if a slab is rotating about a fixed axis perpendicular to the slab and passing through its mass center, the angular momentum is the same when computed about any other point P. Okay, so we have the mass center here, the axis is passing through that point, and then we have another point P here. We're going to go back to page 520. So here we have a rigid body rotating about a fixed axis. In our problem, this fixed axis is at point G. So point O and point G in our problem here are in the same place. So we can either use equation 19.7 to get the angular momentum about G. So that's the moment of inertia about G times the angular velocity. Or you can use equation 19.9. And since your fixed axis is at point G, you could call this the angular momentum about G and the moment of inertia about G. And in that case here, our G would be equal to 0 since these 2 points are at the same place. Okay, so that gives us our equation here. That's from 19.7. Now, look at the next page. So we have a rigid body here. We have the mass center. And we have another point A. So this point A is playing the role of our point P here. Okay, so we have a rigid body subject to general plane motion. We have the equations here, which is the same as what we had on the previous page. If the angular momentum is computed about point A, shown here, it is necessary to include the moment of the linear momentum and the angular momentum about G, about this point. In this case, we get this equation here. Okay, now the key to doing problem 19.3 is to realize that if you have the velocity of point G, well, you have the fixed axis passing through point G. So the velocity of point G is equal to 0. So the rigid body is rotating, but the mass center is staying in the same place. So the velocity of G is equal to 0, which means that this whole term here is equal to 0, which means the angular momentum about A here, or we could say the angular momentum about our point P, is equal to the moment of inertia about G. So moment of inertia about G times the angular velocity plus 0. And this are the same, which is what we were supposed to show. That concludes problem 3.